All right, let's summarize probability. People struggle with probability, so I want to make a one-page quick synopsis of it all, at least for what we do in my class, Algebra 2. Now, for the probability of A and B, if you hear the word A and in a word problem, what you're doing is you're multiplying the two individual probabilities, the two individual events. Now, with an and, there are two possibilities. You get dependent or independent events. Dependent events are like with a deck of cards. When you pull out three cards, what's the probability of pulling out 3 aces? Well, when you take out 3 cards, well, for the first one you pull out, you have a 4 in 52 chance because there are 4 aces in the 52 cards. But for the second card you pull out, the probability of it being ace, if the first one was already an ace, because you need 3 of them, well, what happens is there's one less ace to choose from, and there's one less card in the deck. And for the next one, there are only 2 aces left, and there's 2 less cards in the deck. This is called dependent because what happens is each event depends on what happens in the first event. So the first event affects how many possible in the second event. Okay. Now, if we were to take the cards out and replace it each time, like put a card, take a card out, put it back in, take a card out, put it back in, those would be 52 on the bottom, and those tops would stay as 4s because they are not dependent of each other. They don't affect the second draw. So dependent again means you have one event affecting the next events. And again, it's an and. If I say 3 aces, that means an ace and an ace and an ace. So I'm multiplying. So you first, when you read a problem, when you hear a problem, you have to think, is it an and or an or, which we'll talk about. Ors are here. And for ands, it's multiply. And from there, you got to decide, is it dependent or independent? And dependent means it affects the next one, where independent, which I'm going to talk about right now, is when they're independent, meaning they don't affect the second one. Where the first draw doesn't affect what happens on the second draw. Meaning, if I want a probability of a 5, then a face card. Well, if you think about that, if I draw 2 cards, okay, a 5 and then a face card, but with replacement. With replacement means I put the card back in each time. So I draw 1 card out. For a 5, there are 4 5s out of 52. And, then means and, a face card. Well, a face card, there are 12 face cards out of 52. And why is this 52 on the bottom? Well, when I put the card back in, the first 5, I replaced it, I put it back in, so I now have 52 still in the deck. So realize that with independent events is your probabilities don't change on the second event, meaning you put everything back in and you have the same information on the second draw as the first draw. Basically, independent means the next events up here, see how they got affected by what happened previously? For independent, the second event was not affected by what happened on the first event because we put the card back in the deck. So the key with an and is which type is it. So be very careful, and then you just multiply, and then you reduce, and so forth. We're not going to deal with all the math behind it. We're just setting it up. That's the key. So and, multiply, dependent, independent. Now, for or, what you do is you take the 2 events and you subtract the and, the overlap, where they both happen together. Now, usually with or problems, you're describing one event by 2 things. Now, the 2 things could be called events because the 2 things are like events, but you could also think of them as entities of one event. Like, for instance, if I have probability of a jack or a queen. Now, this is called mutually exclusive because you cannot draw a jack, one card, that is both a jack and a queen. And this is a joker, but we're not going to talk about that. So you cannot technically, for mutually exclusive, they're exclusive, meaning these are separate entities that cannot happen at the same time. So if I want to possibly pull out a jack or a queen, what you do is the probability of a jack is 4 out of 52. The probability of queen is 4 out of 52 because there's 4 of each, minus 0 out of 52 because there's no possibility of pulling a jack and a queen. There are no cards that are both jacks and queens. Jacks and queens. There are none. So they're mutually exclusive, so you really don't even have to worry about the second piece. You just add these 2, we're done. This would be 8 over 52. The problem is, sometimes it's not mutually exclusive, meaning there's overlap. There's cards that hit both types. For instance, this one, the probability of 8 or a heart. Well, a probability of 8, well, there's 4 out of 52 are 8s. Hearts, there's 13 out of 52. But we minus the 1 out of 52. What's the 1? Well, it's a 8 and a heart, called the 8 of hearts. Remember, you subtract the 8 and a heart. And you subtract the 8 of hearts. And the reason you subtract that is because technically you can't count it twice. Because what happens here, you have an 8 of hearts here and an 8 of hearts here. You counted it twice, so we have to subtract that double count. So watch out for times when you double count. You have to subtract the overlap. It's called the and piece. All right, so ors you add, but you have to subtract the and, the overlap. Sometimes, like problem here, mutually exclusive, there is no overlap, so you don't have to subtract anything. Sometimes you have to watch out and subtract something. So we have ands, we have ors. Okay, we have two different types of each. Those are the basic building blocks of that. Now we also have something called conditional probability, which deals with given, the word given. So if I have probability of pulling a red, given it's a face card. Well, the moment I say given it's a face card, I basically told you the only possible cards left are face cards. So all of a sudden, here the given, there are only 12 cards in my deck that are possible, the 12 face cards. So again, the word given actually makes things easier, but for a lot of people, it confuses them. Again, the moment I say given, it tells me face cards. That means all I have left choices are face cards. Now, from what's given, the probability of red. So out of these 12 face cards, there are, out of the given, aren't there 6 reds out of all the face cards? So my probability when you reduce will actually end up being 1/2. Right, the key again for conditional probabilities, there's a condition, there's a if-then statement. There's something that makes something else happen. So given, it's a face card, shrinks what's left, and then we do a probability out of this number. So red, how many reds are left from the 12 that are left over? This can confuse people, but once you get it, it's a pretty simple conditional probability. It could be very simple once you realize the given is your bottom number. It's what you're choosing from.